syndromes affecting the medulla oblongata. If you can remember last time or in the last lecture, I discussed about the medial medullary syndrome. That medial medullary syndrome is also known as Dejerine syndrome. Dejerine syndrome. I think it's I also. Dejerine syndrome. But this one, the lateral medullary syndrome, is also known as Wallenbach syndrome. So while the medial medullary syndrome affecting the medial part of the medulla oblongata, the lateral medullary syndrome affecting the lateral part of the medulla oblongata, while this one is called Wallenbach syndrome, the other one is called Dejerine syndrome. So now, what are the causes of the Wallenbach syndrome or the lateral medullary syndrome affecting the lateral part of the medulla oblongata? The causes or the cause is similar to what is causing the medial medullary syndrome, because if you can remember in the other lecture or in the other video, the medial medullary syndrome, as I said, is being caused by occlusion or blockage of the anterior spinal artery. So this one is also related to the blockage of one artery, what we call pica. That means posterior inferior cerebellar artery. If you can remember, posterior inferior cerebellar artery is a branch of the vertebral artery. You can remember your anatomy very well from the beginning of the cycle of Willis. You have two vertebral arteries, one from the left side, the other one is from the right side. The two together, they come and unite into a single artery known as basilar artery. But before each of these unite to form this basilar artery up, each of these vertebral artery now gives this pica. That means the posterior inferior cerebellar artery. So now, either the blockage of the vertebral artery or the blockage of the posterior inferior cerebellar artery, either of the two arteries that are blocked, can cause this lateral medullary syndrome. Because this artery, the pica, supplies the lateral part of the medulla oblongata. Are you clear? So once this artery is being blocked, it's going to present with these features, of the involvement of the structures that have been, affected by this loss of blood supply to that side. So on the lateral side of the medulla oblongata, you remember your tracts that I discussed with you before. If you remember your anatomy very well, on the lateral side of the medulla oblongata, we have all these important tracts going up. We have our spinal lemniscus, we have our trigeminal lemniscus, we also have our, the other tracts that are carrying some sensory informations. So if we now talk about the features, that's what we call contralateral sensory deficit. If you can remember, we talked about the medial lemniscus. That medial lemniscus, as it begins from the medial side of the medulla oblongata. Later on, it now passes upward. Some of it is, into the lateral part of the medulla oblongata. So there is also loss of this vibration and proprioceptive, loss, and other sensation. The tactile stimulus. When you touch that person with this lateral medullary syndrome, the touch, either crude or fine touch, is also being affected because, the lateral side of the medulla oblongata, that tract that is located there, is being affected. So both the limbs and the trunk of that side, opposite side of the lesion, is going to be, the sensation there is going to be deficient. That is why we said that's contralateral sensory deficit from the trunk and the upper and the lower limb of the opposite side of the lesion. So this sensation includes our vibration sense, our proprioceptive sense, tactile, sensation, that is crude and fine touch, and so on and so forth. There's also ipsilateral sensory deficit of the face. You remember that in the face, what is carrying all this sensation in the face, whether touch, pressure, vibration sense, proprioception, and so on and so forth, pain and temperature, they are all being carried through the trigeminal nerve. So the trigeminal nerve, doesn't cross. You have one trigeminal nerve of the left half of the face, carrying sensation from the left half of the face. You have the left trigeminal nerve carrying this sensation from the left half of the face. So you have two trigeminal nerves carrying this information. Right one and the left one carrying all this information of this sensation that I've said. So since this trigeminal lemniscus passes through the medulla oblongata, you get it. So the trigeminal nerve is going to be affected because of this lesion or blockage of the pica there. So if that trigeminal nerve, the trigeminal lemniscus has been affected in there, you get it. You have our spinal nucleus of the trigeminal nerve. So if it is affected, so there is this ipsilateral sensory deficit of the same side of the lesion on the face. So if it is the left part of the medulla oblongata that has been affected, you get it. That means the left half of the face, all those sensations on that left side of the face is going to be deficient. You get it. Similarly, there's also contralateral loss of pain and temperature. Remember your pain and temperature pathway. You get it, your spinothalamic tract. The spinothalamic tract, within the substance of the spinal cord, as the information comes from the right-hand side, within the spinal cord, the fibers of these axons that are, carrying the sensation from the right side, as they come into the spinal cord, they cross to the opposite side and then ascend up. You get it? So if this left half of the medulla oblongata is affected, this spinothalamic tract of this side is going to be affected. So the information with regard to the pain and temperature of this side is one that is going to be affected. That is why there's a contralateral loss of pain and temperature opposite to the side of the lesion. Because from this side, it crosses up to this side. So if you cut this way, you cut the tract this way, this side is going to be affected. Are you clear? So there is loss of pain and temperature from the opposite part of the lesion. Other features related to this Wallenberg syndrome include what we call dysphagia. You remember that we have nuclei, in the medulla oblongata, where I discussed about the important nuclei there. Nuclei related to the vagus nerve, nuclei related to the glossopharyngeal nerve, responsible for our breathing pattern and swallowing and vomiting and what have you. So the dysphagia is as a result of paralysis of the muscles responsible for our swallowing, our pharyngeal muscles. Are you clear? So the pharyngeal muscles are also going to be affected, so there's difficulty in swallowing. That is what we call dysphagia. There's also this atria, what we call slurred speech, because our laryngeal muscles, are responsible for our phonation. To be able to speak is the function of our muscles around the larynx that allow us to speak well. So because the vagus nerve, is the nerve that supplies the laryngeal muscles from the recurrent laryngeal nerve, you get it. So that nerve, since the vagus nucleus is affected in the medulla oblongata, there is problem with speech because the muscles of phonation are affected. You get it. So there's this atria. Similarly, there's also what you call dysphonia. You get it. Dysphonia is lack of quality of speech. There's also ataxia. That means loss of balance. If you can remember, I talked about the inferior cerebellar peduncle. You remember your vestibulocerebellar pathway. The vestibulocerebellar pathway from the internal ear also passes through the inferior cerebellar peduncle. So the vestibulocerebellar fibers through the inferior cerebellar peduncle responsible for our balancing while you are standing or you are sitting. That's what we call ataxia if that lateral side, because the inferior cerebellar peduncle is on the lateral side of the medulla. So once you have involvement of the lateral side of the medulla oblongata, the inferior cerebellar peduncle carrying this vestibulocerebellar tract responsible for our maintenance of balance So that's what we call ataxia, loss of balance. You will see the person swaying as if he or she is going to fall. Even while you are sitting down, the person is not well balanced. Are you clear? That's what we call ataxia or ataxic gait if a person is walking around. There's also vertigo. You see the whole room, swaying around. It's like you have been, cycled around the room. There's also nystagmus, whereby you have your eyes, are just oscillating up, down, left, right, and what have you. So all this as a result of this balance, vestibulocerebellar tract. So these are the features of somebody with lateral medullary syndrome affecting the lateral part of the cerebellum, and is also known as Wallenbach syndrome. And the other one for the medial I said is called, the Dejerine syndrome. That is it. And the next lecture I'm going to discuss the lesion of the pons. Then finally we'll discuss the midbrain.